So we have been discussing about this micro system for micro robot, in which we have been discussing about the integration. So we had discussed about the different micro assemblies, different techniques which are evolved with reference to these micro assemblies. So we also had some discussion about the overall forces which are exerted for these micro assemblies, ideally in the form of surface tension, van der Waals forces and electrostatic charges, and we also had some discussion about the surface tension and gravity, the overall mechanical microsystems, the overview of the technologies ideally. So we have classified with reference to the different building block, with reference to different techniques, and then with reference to different applications. So in addition to this, we also had some discussion about the overall electrical field, the technology, and the different features which are being evolved in detail. Now, we will be discussing about the overall forces which are participating towards such kind of micro assembly related application. So among these forces, first let us discuss about the electrostatic forces. So as far as these electrostatic forces are concerned, these are the force between a charged sphere and a conducting plate. So the overall generalized equation is F equals Q squared by 4 pi epsilon 2R square, where Q is the charge, epsilon is the permittivity or the dielectric, R is the object radius, and the assumed charge density is approximately 1.6 into 10 power 6. So ideally in this particular case, so let us consider there is a micro gripper which is holding a kind of a sphere object. So the overall force which is being exerted, which we consider it as F grip. So there are two layers are there. One is a kind of an oxide layer, and then there is a gripper layer which exhibits, and then by appropriate electrostatic forces, these oxide layers and the gripper layer will try to get actuated, and it will generate a force along the diameter of the system. Now when we try to consider the van der Waals forces, so as far as these van der Waals forces are concerned, so these van der Waals forces are for a sphere and a plane, and it is giving an approximately by this equation called Bowling. So F equals HR by 8 pi Z square. H is the Lifshitz van der Waals constant, and Z is the atomic separation between the surfaces. Now, as far as these forces are also concerned, we have seen this during the gripping application perspective point of view, these forces are also participating towards gripping related applications. Then we have these hydrophilic surfaces. So as far as these hydrophilic surfaces are concerned, there may be a liquid film between the spherical object and the planar surface, which is contributing a large capillary force, that the surface tension force. So the surface tension force F is gamma cos theta 1 plus cos theta 2 alpha by D. So gamma is the surface tension, alpha is the A is the contact area, D is the gap between the surfaces, theta 1 and theta 2 are the contact angle between the liquid and the surfaces, which exhibits over here. Now let us take a kind of a comparison between the different forces, how these different forces are participating and how it has an impact. So in fact, this is a kind of a comparative chart which gives us a clarity with reference to the influence of the gravity as well as influence of van der Waals forces, the electrostatic forces, as well as the surface tension which exhibits. So when we consider a spherical part of silicon, so the overall gravitational force which exists here is F equals 4 by 3 pi r cube psig. So where for accurate placement, the addition forces should be the order of magnitude less than the gravitational forces. So the capillary forces basically dominate and must be prevented to allow the accurate placement. As far as van der Waals forces are concerned, so these van der Waals forces can start to be significant with smooth surfaces at about 100 micrometer radius, and it can generate a kind of an electric charges from the contact which could prevent from dry manipulation of part less than 10 micrometer in size. Now when we try to consider these forces, so the selection of these forces or the impact of these forces are appropriately considered with reference to the force generated as well as with reference to the overall object radius which is used for the manipulation. Now let us see some of the different types of micro assemblies which are being exhibited for the micro robot perspective point of view. So first let us consider the serial micro assembly. So as far as this serial micro assembly is concerned, it's a kind of a sequential process where micro components are assembled one at a time. So some of the key features includes which uses a kind of a micro manipulator, a micro gripper and a positioning system, and it also requires a kind of a real-time feedback from the microscope or force sensor. So there is a kind of an offline calibration or sensory feedback control which enhances the precision. So some of the key challenges which ideally includes a kind of a time consuming or a high precision requirement or increased cost. As far as application perspective point of view, so we have the MEMS integration where a kind of an micro optical benches and micro spectrometers are used, and then there is a kind of a micro robots in place. So when we try to closely observe these micro manipulation perspective point of view, so we have a kind of a so some of the key components which are being participating over here are micro manipulator, a micro gripper or a tool, a micro part and a microstructure. With reference to a micro manipulator and a micro gripper tool, we have a micro interference which is being participating over here. With reference to a micro gripper tool and a micro part, there is a kind of a temporary micro interference interface which exhibits, and from the micro part to the micro structure, so there is a kind of a permanent joint which is a kind of a micro interface which exists. Basically this will give an overview about the different subsystems and the interface for a kind of a serial micro assembly. So as far as some of the key challenges which are involved in it is a bit time consuming. However, for kind of a high precision requirement, there is an increase in the cost. As far as application perspective point of view, it has a kind of a, it has an application towards MEMS integration as far as a micro robotic applications. Now, this is the case with reference to a serial micro assembly. Now let us discuss about the parallel micro assembly. So this is the overall like a schematic of a parallel micro assembly where the the overall assembly is done simultaneously, where the simultaneous assembly of a multiple component using a multi-gripper system or a self assembly can be deployed. So some of the key features of these systems are it uses a kind of a gripper array. So either it has a kind of a electrostatic or a magnetic force or a fluidic self assembly systems, and it has an increased throughput compared to the serial method. So as far as advantages perspective point of view, it has a high efficiency and it has a high productivity. And with reference to cost effective perspective point of view, it is a highly cost effective for a kind of a large scale production. As far as application perspective point of view, like kind of a flip chip technologies are being used by this system, and it is widely used for a kind of a self assembly of microstructures. So these are some of the key applications which exhibits. Now let us take let us look into the overall comparison with reference to this serial micro assembly and the parallel micro assembly. So if we closely observe the overall features which are involved in it, so we have the serial micro assembly and the parallel micro assembly in place. With reference to speed perspective point of view, this serial micro assembly is bit slow, whereas with this parallel micro assembly is concerned, it is bit fast. With reference to precision perspective point of view, it is high and it is moderate, and with reference to cost perspective point of view, it has high and it has a low power input. And on automation perspective point of view, it requires a real-time feedback, a kind of a self-organizing or a multi-gripper system. On an application perspective point of view, it is widely used for high precision MEMS application. It has a kind of a large scale micro device assembly. Like when we try to look into the overall summary, like serial, it is highly used for a kind of a best high precision and small scale applications. As far as parallel it is concerned, it is ideal for a high volume and a kind of a cost effective manufacturing. When we try to consider the future direction perspective point of view, these hybrid systems are for higher efficiency and it has a kind of a higher flexibility. So these are some of the key summaries with reference to the micro assembly for micro robotic system. Now let us discuss about the different relationship which exhibits with reference to this micro assembly for micro-robotic application perspective point of view. So one of the key aspect is called a stochastic effect. So as far as the stochastic effect is concerned, it is a kind of a relationship between the part and its destination is unknown or random. So the parts are self-assembled during the stochastic process. So it has a kind of a fluidic agitation and mating part shapes and a kind of a vibratory agitation and an electrostatic force fields. When we try to look into the vibratory agitation perspective point of view, so there are two different force field which exist. One is a kind of a electrostatic force field, another one is a kind of a mating of part shapes for an effective assembly. So as far as these mating patterns are concerned, so these mating patterns are for kind of a self-assembling monolayers. So these are some kind of micro parts, and there are certain amount of receptor sites which are being available over here. These micro parts are fed close to the receptor sites. So after agitating the part, so most receptor sites are filled by a micro part. So there is always a possibility of error. Example, one receptor site not filling as shown in figure is usually more micro part which are receptor sites are used for such kind of system. Now, so this is a kind of a stochastic process where there is always a relationship between the micro part and the receptor site. So like it tries to communicate each other for appropriate mating or appropriate like bonding or interface of the systems. Now let us talk about the self-assembly. So as far as the self-assembly perspective point of view, so the self-assembly leverages a physical forces. Ideally it has a capillary, it has a magnetic and an electrostatic to automatically position the component without direct manipulation. This approach offers high throughput but reduced precision compared to deterministic method. Some of the key techniques include, one is a kind of a shape directed assembly, another one is a kind of a fluidic self-assembly, third one is a kind of a surface tension driven assembly, fourth is a kind of a magnetic self-assembly. So like as far as so these are some of the configurations with reference to assembly. Now the primary advantage of this particular system is, like if you observe this particular figure, so there is a kind of a ball and a cup which is available. So a ball is released to a cup and a potential energy converted into a kinetic energy. So in this particular case, the ball is attracted towards the energy minimum which is at the bottom of the cup. Slowly the kinetic energy is dissipated as the heat and the ball settles to the center of the cup. Now when we try to look into the overall key techniques which are involved, like as discussed earlier, so this is a kind of a shape directed assembly where based on the shape or based on the geometry, appropriately we can orient the assembly for a particular alignment. As far as fluidic self assembly is concerned, let us consider if this is a structure where there is a kind of a fluidic which is placed over here. In most of the cases, because of the fluidic interaction, there is a kind of a circular curvature which is available, and the particles will try to get like accumulated at the circular curvature region. So appropriately there will be a kind of a motion. Next is a kind of surface tension based driven assembly. So as far as this surface tension based driven assembly is concerned, so like based on the surface tension, so appropriate assemblies can be like adjusted. Then we have a kind of a magnetic self assembly. So through a magnetic field, appropriately we can align the system. So as discussed, some of the major advantage of this system is it has a kind of a parallel operation and it allows a many component to assemble simultaneously. Most important point is, since the overall aspect is controlled with reference to shape, with reference to fluid, with reference to surface tension and with reference to magnetic, so it is easy to automate this system to get the required assembly models. Now as far as these directed micro assemblies are concerned, so these it's a kind of a controlled approach to assemble these micro scale objects by leveraging the specific interaction. So as far as in this particular case is concerned, like let us take an example here. This is a kind of system, there is a kind of an inverted microscope is there, and then a fluidic sources are being evolved over here. So there is an electromagnet which is being placed at the boundaries and at the fluidic interface. Now by giving an appropriate field to this electromagnetic, these fluidic interfaces will get aligned, and then it creates a kind of a sub assembly, and these assembling will be subjected to, so the leveraging of this assembly is taken care by the magnetic field which is being evolved. So as far as this particular case is concerned, when we try to define this directed microassembly, it's a kind of a controlled approach for assembling the micro scale object by leveraging a specific interaction. Importance perspective point of view, it enables a precise micro manipulation for manufacturing complex microstructures. So some of the techniques which are used are the kind of a capillary interaction, and another one is a kind of a magnetic microrobot. So these are some of the techniques which are being effectively used for a kind of a directed microassembly. Now let us take a kind of a capillary interaction in microassembly. So as far as this capillary interaction is concerned, it comes under the category of a fluid domain. So the concept which is evolved in this is, so the microparticles at the fluid interface disturb the interface shape and migrate to minimize the interfacial area. So it is independent of the material property and it allowing the assembly of diverse particles. So as far as application perspective point of view, there is a kind of a microfabrication which exhibits, and the biomedical devices are there, and the smart materials. Okay, so these are some of the applications which basically caters to this particular concept. Now in similar fashion, when we try to consider a kind of a magnetic micro robots, so it has a mechanism. So as far as mechanism perspective point of view, it's a mobile micro robot which distorts fluid interface and generating an attractive capillary forces. These robots can precisely position and assemble the microparticles. Some of the key advantages which involve the non-contact manipulation, it works as a kind of a passive microparticles that do not respond to the electric and the magnetic field. So ideally this works on the magnetic domain and this works on the fluid domain. Now let us see the overall behavior of these magnetic assemblies. So as far as these magnetic assemblies are concerned, so these magnetic assemblies will basically collaborate with arbitrary geometries and functions. So these magnetic assemblies can accomplish several configurations in different dimensions, designing devices with arbitrary structure, which remains as a significant challenge because of an unclear design and rules. So as far as these magnetic assemblies are concerned, it enables the controllable and selective docking and assembly of a magnetic devices with desired microscopic pattern or a mechanical structures. So the manipulation of these microstructural units of these kind of magnetic assemblies, it paves the way from micro devices to micro robot. Therefore, this section delves into a kind of a magnetic unit and their magnetization under different magnetic field. So some of the key parameters which are involved in this particular systems are, one is a kind of a force and a torque of the magnetic unit. So in the magnetic field can be calculated by this particular equation, so which involves the magnetic force. The MP and BP are the induced magnetic dipole moment of the cluster and the magnetic field at the point P. So the magnetic field at the point P is represented as TP equals MP into PP, which basically narrow down towards the magnetic torque which exhibits. So let us take a simple case study where such kind of magnetic assemblies are being deployed. So in this particular case study, so this is a kind of a reconfigurable self-assembly of photocatalytic magnetic micro robots magnetic micro robots. So ideally these kind of micro robots are used for water purification. Okay, so as far as in this particular case is concerned, so the overall structure has a kind of a lobe it's a kind of a self-propelled light-powered magnetic micro robot. So it has a kind of a lobe kind of structure, and inside this lobe kind of structure, so it has a kind of a core shell arrangement. This core shell arrangement is basically comprises of TiO2 and alpha Fe2O3. Okay, so this lobe kind of structure is basically controlled by two different medium. One is a kind of a magnetic field, and the other one is a kind of a, since a kind of a photocatalytic, it is converted through light. So as far as in this particular case is concerned, so we have a kind of three different aspects. One is a kind of a like phoretic interaction, and the other one is a kind of an active cluster. So this, and the third one is a kind of a magnetic dipole and the dipole interaction. So ideally it forms a chain. This is a kind of a magnetic dipole-dipole interaction. These are kind of an active clusters, and this is a kind of a phoretic interaction. Okay, so as far as in this particular case is concerned, so this is a kind of a self-propelled light powered magnetic system. Magnetic robot, and this is a kind of a, like it's a kind of a reconfigurable system. So as far as these systems are concerned, like these are mainly meant for development of artificial small scale robots, robotics with a kind of a nature based biomimicking arrangement. So as far as in this particular case, like we have a kind of a collective behavior which represents the frontier of research in the robotics. So while a micro robot swarming under a magnetic manipulation, it has been like there is a kind of a light induced self organization of micro nano robot can be deployed, and the interaction is controlled, and the reconfigurable and the reversible, and it's a kind of an active self assembly of TiO2 alpha Fe2O3 micro robots. So it's a kind of a peanut based shaped system, and these microparticles are synthesized by a different route. Some of the major routes, which basically includes a kind of a hydrothermal process, which is covered with a thin layer of TiO2 by an ALD deposition. So basically there will be a two layer, one is a core and the other one is a kind of a clad. So the core is a kind of a alpha Fe2O3, it's a kind of a hematite, and the clad is completely covered using a TiO2 layer with a, which is a kind of a ALD process. So due to their photocatalytic and ferromagnetic properties, these micro robots can autonomously move in an underwater condition using a light irradiation. So while a magnetic field is precisely controls their direction, so in the presence of H2O2 fuel concentration, the gradient along the illuminated micro robots result in a kind of a mutual attraction by the phoretic interactions, inducing their spontaneous organization into a kind of a self-propelled cluster. So in the dark cluster, there is going to be a kind of a reversibly reconfigure into a micro chain, where the micro robots are aligned and the photocatalytic properties where can be appropriately used for a kind of a process. So as far as in this particular case is concerned, so it is more to do with the structure, and the orientation or the self alignment of the structure is taken care by the appropriate, like by applying an appropriate magnetic field to the system. So like there are two different types of propulsion which exhibits over here. So if you try to look into the overall propulsion perspective point of view, like there is going to be a magnetic field, and then there is going to be a light powered propulsion and the magnetic field. So both will collaborate to assemble these particles and appropriately configure these micro robots for efficient, like photocatalytic perspective point of view. Okay, so when we try to look into the overall comparison of these directed assembly as well as traditional assembly, so like when we try to look into the overall manipulation mechanism, so we have the kind of so based on the features, so appropriately we can orient the manipulated mechanism. So one is a kind of a capillary force on the magnetic field, like and the traditional micro assembly basically involves a mechanical or electrostatic. As far as precision perspective point of view, these kind of capillary and the magnetic field are of high precision. However, with reference to traditional micro assembly perspective point of view, these are kind of a moderate, and like as we had seen earlier also, along with electrostatic charge, there is a chance that magnetic field, the gravitational force will also try to participate and will also try to resist the overall movement of it. As far as compatibility perspective point of view, it works with the passive particles, and on traditional perspective point of view, it's a kind of a material dependent. Control perspective point of view, with reference to direct microassembly, so we can control the microassembly with an external magnetic field, and the traditional microassembly is concerned, it's a kind of a direct physical manipulation. So in summary, like these direct microassembly utilizes a capillary force for a precise assembly, and with reference to like these magnetic micro robots are concerned, so these magnetic micro robots ideally enable a kind of a non-contact manipulation of microparticles, and like based on the application, so appropriately there are different challenges which exhibits with reference to micro manufacturing and other characteristics perspective point of view. So let us discuss about the other aspects related to this hybrid micro assembly in the next class.